Hey guys, it's Miss Turnbull here with your Thursday video. It is the last video of the year. That's right, you made it, and we're going to get through this together, and then after that there will be no more new content, and it'll just be up to you guys to finish up what you've been working on. So let's dive in here. We're going to talk about rates of change today. This is going to feel a little bit like review, okay? It's going to remind you a lot about the stuff that we covered earlier in the year when we talked about rates and ratios, unit rates, and things like that. So first, we're going to talk about what is the difference between a rate and a ratio. We're going to take a look at this chart. So a ratio is a comparison of two or more quantities that have the same unit, whereas a rate is going to be a comparison of two or more quantities still, but these have different units, okay? A ratio might say, okay, we have 4 people at this dance from this school for every 2 people at this dance from this other school. A rate, on the other hand, you'll see these really often in things like fuel efficiency. So here in Canada, we see a lot of vehicles being advertised with how many liters per 100 kilometers, or if you're looking at American advertisements, they might give you miles per gallon. Okay, that is a rate. You have 2 different units. You're comparing 2 quantities. So for example, on the left, we have 4 boys to every 6 girls in this math class. And on the right, for rate, we have an example saying this car burns 20 liters of gas for every 200 kilometers traveled, which would be 10 liters per 100 kilometers. That's the more common rate that we see it expressed in. So in both cases, you want to express these in the lowest terms possible. In real world application, for the example given here with liters per 100 kilometers, typically speaking, here you'll see those advertisements with liters per 100 kilometers. They will not put it in the lowest possible terms. But for this course, we need to have you guys practicing putting things in the lowest possible terms. So we will continue to do that. Okay, so for this example, it says for every 28 grams of chips in a small bag of Fiery Fusion Doritos, there are 140 calories. Determine how many calories are in a small 78 bag of Doritos. So this is a ratio. We have 28 grams, or a rate rather, and we have 140 calories. Okay, so we have 2 different units being used here. We can still solve this using the same strategies that we were solving them with at the beginning of the year. So there are 140 calories in 28 grams. Okay, we want to know how many calories are in 100 or are in 78. That looks like T8. Let's fix that. Are in 78 grams. Okay, and then we can just cross multiply. So we've got 140 times 78 divided by 28. And that tells us that in 78 grams, you have 390 calories. Okay, so just using that simple, setting up our ratios and using cross multiplication. All right, this doesn't have to be complicated. Many of you really liked doing this with cross multiplication, so that's how we're going to teach it here. So for example 2, it's talking about in a global village of 100 people. So this is a hypothetical village of 100 people that has proportions equal to the different populations of the earth. So in 100 people of a global village, you would have 61 people from Asia, 13 from Africa, 12 from Europe, 8 from South America, including Central America, Mexico, and the Caribbean, 5 people from the United States and Canada, and 1 person from Oceania. That's Australia, New Zealand, and the Pacific Islands. So it's asking us to record the following ratios. Remember that ratios typically have the full colon in between them. So it wants people from Europe first. So it's going to be 12. And people from Asia next, which is 61. And then we have to ask ourselves, okay, is there a common denominator here? Well, 61 is a prime number, so no, it's going to be 12 to 61. Now let's take a look at this one. People from America first. I'm going to say this is people from South America. So 8 people from South America and people from Oceania. So that's 1, 8 to 1. And the last one, people from Africa, 13. People from the United States and Canada, and that's 5. Okay, really simple, setting up our ratios like that. So let's take a look at this question here. It says there are approximately 1,200 students in a school. If the student body resembled the global village described, how many people would be from each of the 6 regions? Show your work and describe the strategy you use. So I'm going to move this up so that we have a bit more space. Turns out we did not need all this space. Okay. So 1,200 students in a school. So let's do Asia first. So in Asia, it's 61 in 100. And we want to know how many that's going to be in 1,200. So we're going to do cross multiplication. 61 times 1,200. And then divide that by 100. That tells us there would be 732 from Asia. Okay, next one. 13 people from Africa. So 13 out of 100 is how many out of 1,200? Take our calculator. 13 times 1,200. Divide that by 100. And it tells us it's 156. And that is from Africa. Okay, next one. We have 12 from Europe. 12 out of 100 is how many out of 1,200? That tells us it's 144. $144 from Europe. 3 more. 8 from South America. So 8 divided by 100 is how many out of 1,200? 8 times 1,200 divided by 100 gives us 96. Is South America? Yeah. Okay, and then we've got 5 from the US and Canada. So 5 out of 100 equals blank out of 1,200. So 5 times 1,200 divided by 100 tells us there would be 60. Okay, and then last one, 1 person from Oceania. If I do this math, it's going to be 12 people from Oceania. Okay, we practiced these kinds of questions a lot at the beginning of the school year. Okay, this isn't any different. Remind yourself how to set up your ratios and how to do your cross multiplication, and you will be good to go. All right, example 3. After a 6-hour snowstorm, there was 24 centimeters of new snow on the roads. At what average rate did the snowfall fall during the storm? We have 6 hours, 24 centimeters. What we want to find out is how many centimeters per hour. So we have 24 centimeters per 6 hours. What we want to know is how many per hour. So we're going to divide both of these by 6. And what that gives us is 4 centimeters per hour. Okay, ask yourself, is this a rate or a ratio? Remember that a ratio has to have the same units. Here, we have 2 different units. So this is a rate. Okay, at the 5-hour mark, how much snow had fallen? Well, now we can take this one here, okay, 4 centimeters in 1 hour, and ask ourselves, okay, how many centimeters in 5 hours? Well, 4 times 5 is 20, divided by 1 is going to be 20 centimeters. So 20 centimeters had fallen at the 5-hour mark. Okay, so last question here says, during a trip from Chatham to Ottawa, Nelson traveled 700 kilometers and used 80 liters of fuel. What was this car's fuel consumption rate in liters per 100 kilometers for highway driving? So we've been given 80 liters per 700 kilometers. We want this to be per 100 kilometers. 700 kilometers is 7 times that. So we're going to divide this and the other side by 7. So 80 divided by 7 gives us 11.4. So it's going to be 11.4 liters per 100 kilometers. Driving back and forth to work within Chatham, Nelson traveled 490 kilometers and used 65 liters of fuel. What was the fuel consumption rate for driving in the city? Same thing. So we were given 65 liters per 490 kilometers. Now this is a little bit more complicated, right? They gave us 490. It doesn't round nice and easy into 100 liters or 100 kilometers rather. But I know that this divided by 100 is 4.9. So I'm going to divide both sides by 4.9. So let's pull up our calculator here. We've got 65 divided by 4.9. And we get 13.3. It's going to be 13.3 liters per 100 kilometers. So now it wants to know, okay, well, how far can Nelson expect to travel on 45 liters of gas within the city? Well, now we're going to use our cross multiplication and division. So 13.3 liters for 100 kilometers in the city. Make sure you're using the right rate, right? Once in the city. So now we're going to use the city rate is 45 liters for how far? Okay, now we're going to cross multiply and divide. 45 times 100, divide that by 13.3. What we get is 338.3 kilometers. So it's a word problem. Need a word answer. Nelson can expect travel 338.3 kilometers using 45 liters. Okay, so again, put your ratio together, put it into your fractions for cross multiplication, and cross multiply it out, and you'll get the right answer every time. All right, guys, that is it for this video. As a reminder, if you are struggling with any of this stuff, please don't forget to ask your teachers for help. I hope you are having a great week, and we'll see you next year.